Okay, so in our work so far with trigonometry, we've been talking about the unit circle. Oops, sorry, that's not straight. And we said, okay, well, if you have a point on the unit circle, then this is 1 because it's a unit circle, meaning it has a radius of 1. And then we said, well, there's a line here and a line here. Let me put those in a different color. And that distance was y. So there was a point up here, x comma y, and we said this distance represents the y. And then we said this distance represents the x. But we had a little triangle here, a little right triangle, and we talked a little bit about that. But then we went on and said, okay, well, x is equal to the cosine of some angle. I think we had t, angle t, forgot to put that in. Anyway, that was going to be x, and then the sine of t was going to equal y. And we worked with that, and it's all true, and it's all good. We were working with angles that were in standard position on the unit circle, okay? All right, but not everything is on the unit circle. So sometimes we have to work with right triangles that may not have a hypotenuse of 1, and they may have, they may be bigger or something, and they may not even be in like a standard position, okay? All right, so we have other ways of looking at the trigonometric functions based on just any right triangle, okay? So we're going to label this angle here. I'm going to label it alpha, okay? And we'll just talk about then the relationship here. So what we do is we say, okay, here's the angle that we're using. We call the side that's across from the angle over here, we call that the opposite side. Then we call the side that's actually touching the angle the adjacent side. Oops, can't spell adjacent. And then the hypotenuse is always the long side, or it's the side across from the right angle. Hypotenuse, okay? So then we talk about sine, cosine, and tangent in terms of the sides of the triangle. So it's called the right triangle approach to trigonometry. And you might say, well, then why did we learn about the unit circle? We need both, so that's just the way it is. Okay. So now we can say for our angle here, we can say that the sine of alpha is equal to opposite over hypotenuse. Okay, the cosine of alpha is equal to adjacent over hypotenuse. And then tangent of alpha is equal to opposite over adjacent. Okay, so you want to learn these. You want to learn those relationships, okay? There's a little acronym, Sohcahtoa, I think that's how they say it. I didn't learn the acronym, but so I don't usually use it. But if you look at sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. It's just to help you remember the ratios, okay? So that's what they are. Now you might say, well, what about the other trigonometric functions? Remember, they're all the reciprocals. So you could say cosecant of alpha. They're going to talk about this later, but it's hypotenuse over opposite. And then secant of alpha, that's the reciprocal of cosine, so it's going to be hypotenuse over adjacent. And then tangent alpha is going to be adjacent over opposite. Okay, so that's true too, but they just didn't mention it yet. Okay, so that is the right triangle approach. And the great thing is, if you know the sides of your triangle, then you can figure out the trigonometric values. Or if you know the angle and you're trying to figure out sides, you can do that. So we'll use this right triangle approach to do some other things.